These are just some different shots of meteors coming in. I wanted to show it because the thing we saw the other night didn't act like this. It acted more, these are coming in very, very fast compared to what we saw the other night, which is why I believe it was space junk, which was a really cool shot because those are very hard to find and see. So today we're going to talk about killer asteroids. Do I need to tell everybody who I am? I worked for NASA for 29 years. For some reason, I think I can get up here and talk. So I'm not doing too terrible so far. I haven't stumbled too much. Okay, that's real life. So I just wanted to show a few things that people have portrayed in the movies, and I guess if it was something really, really huge, then it might look like that. But this is typically more along the lines, by the time it actually burns up, it starts out maybe the size of a car, and it burns up and whatever finally might make it to the ground. Sometimes it's coming in so steep, and we'll talk about that a little bit, that it actually explodes. It's got so much energy behind it. So today we're going to talk about killer asteroids. So that's been in the news quite a bit. This is the first time I've ever talked about this. I wrote this, and I haven't given it to an audience. I haven't even given it to my dog yet, so probably upset at me for not doing that. So if we have questions running through it or I get stuck, then you'll just have to make fun of me or something. I don't know. So what's the difference? I was going to cover a little bit about different things. So the definition of a comet is basically long-haired thing in space is what that kind of boils down to. We're talking about rocks. They're rocks. They're all rocks. So there's a few things different here and there about rocks, but they're all rocks. So comets are rocks with ice and stuff on it that make a trail, things that are being vaporized off. A lot of the times they go by the sun or something, and if they're grabbed by Jupiter and they go into an orbit around us like Halley's Comet and Hale-Bopp. They go around an orbit that's a long orbit, maybe 60, maybe 100 years, they come back. So whatever burned up around going the sun and vaporized is kind of still following it along, and that's where the tail comes from. And as it goes back and swings by the sun, you'll get jets that come off of new things that are being burned off, and then that will become more of the comet's tail. Then we'll see. Sometimes they come close enough to the Earth where they look easy to see, and sometimes not. So that's kind of the comet thing. And so an asteroid is not a comet, but it could have been a comet. It could have been one that basically a comet that everything burned off and there's nothing left there. But it's a very large rock. It is usually in orbit around the solar system because it was coming through our solar system from either someplace else in our solar system, but Jupiter grabbed it, and it's called a jovial comet. It grabbed it, its gravity caught it, and threw it into orbit, a smaller orbit. Something may have hit something going through the asteroid belt, and those are flying around. So most of what we see are asteroids, meteors that are stuck close to the orbit of Jupiter. This is one that I found in Australia. Can anybody say that? Does anybody know what this is? Okay, this is in Australia. If you want to go to Australia, there's this name of this meteorite hit the ground. There's a plane there. Some of these are up to 12.5 tons. I think they found close to 22 tons of meteors. I cannot pick it up. I did not try. So when these meteors, smaller, meaning asteroids are bigger, meteors mean smaller, something along the size of a car, whereas asteroids are usually way, way bigger than a car. We're going to go over some of those and talk about those specifically, but I figured we'd get the meteors and the meteorites out of. So when it's in the air, it's a meteor or a meteor with a D, and when it's on the ground, it's an ite, becomes a rock. And so it's something from outer space falling to Earth. It's coming through the atmosphere. The atmosphere is interacting with it. There's friction. There's heat being generated on the front of it. It's usually spiraling, depending on the materials. They're boiled off, and that's how we see the colors. Most all of them, one of this size would most likely completely burn up before it hit the ground. A lot of the ones that we see are micrometeors. They're even the size of a grain of dust, a grain of sand, and there's some even smaller than that we'll see as well. Some do hit the ground and do make impacts. That actually was a picture of one that they caught on their door cam that actually hit their ground, and I guess they got to keep what was left. Has anybody been to Meteor Crater in Arizona, or a crater where they sell you little pieces of the meteor? I've got some at home. Very cool. Very cool. Now, when these meteorites, the meteorites are smaller, they're on the lines of a car, they can be dust particles, they can be fragments of broken up comets, but sometimes big things hit the Earth, hit the moon and Mars, and when they hit it, it's ejected, and some of that stuff falls to Earth. And in Antarctica, or where there's big glacier fields, every now and then you'll find a rock laying out on there. It's a meteorite, so there's nothing else it could be. And so they go up, and some of these are just normal meteorites, and some of them turned out that they are from Mars. And we've actually had some pretty famous ones that we've gotten from Mars. And by doing chemical analysis on them and strange engineering things, chemical engineering things, they can actually figure out what chemicals are in there and where it came from. So the question becomes how do we know all this? How do we look up at the sky and say, okay, that's a meteor, here's where it's going, here, this one's going to come close to us, this one's not. And so the idea behind that is that there's a huge amount of math called vector calculus. Who's had vector calculus? Calc 3. Okay, I'm sorry for all of you too. So it is quite useful if you still remember how to use it. But they will take a picture of it, and then they see where it goes from there, and they'll get a vector, and from there they can figure out how fast it's moving, which direction. And after 3 or 4 shots at this, they can find out where it's going to go. And if it's going to come near Earth, there's a whole another protocol that takes place for near-Earth asteroids, and they can start calculating whether it's going to hit the Earth. And this is what happened with asteroid 2024, which is now named Apophis, that's going to come by, and we'll talk about that later. Originally, they thought that it had like a 3% chance of hitting the Earth, but after the more pictures they took, the more vectors they got off of it, of which way it was going, they could figure out that it's not going to hit us, which is great. So we got all this math stuff here, and we could get into all these laws and everything if everybody wants to, but basically there's a guy named Kepler that came up with orbital mechanics. Mr. Newton came up with calculus. Galileo, this guy had a lot of observations, didn't understand them all, but he took a lot of pictures. They combined all that stuff to start telling us how we could figure out where these things were. So what we're looking about today, we're going to concentrate on asteroids. Originally, I was going to do them all and realized that was crazy. So just how many asteroids are out there? This is not going to make you go back to your room with a warm tummy feeling. So if you want a warm tummy feeling, now would be the time to get some ice cream and cake. So is that making you feel better? So we've got about 500 100,000 unnamed asteroids, 30,000 ones that are going to come close enough to the Earth to worry about. Just in general, 1.7 million larger asteroids, half a mile in size or bigger. We don't even know how many untold smaller, millions of smaller ones. And then apparently we have some that are turned in from Pluto that's now claimed as a dwarf or minor planet, with 60,000 of those. So there's a lot of stuff out there. So everybody feel much better now, right? So we're going to go back and think, hey, we don't have to worry about asteroids. Okay, right, yeah. I think the asteroid budget just went up. So about every 2,000 years, we have something the size of a football field that comes down and hits us. That will hit us. Sometimes they just explode, depending on the angle. If they come in at a very shallow angle, sometimes they just hop off the atmosphere. Depending on the angle they come in, if they come in too fast, they get too much energy, they'll actually explode, and I'll show you one of those later. It's quite often, maybe once a year, we'll have something the size of, I don't know, a Camaro. Is that a Camaro? So, yeah. And then some of them have their own little moons going around them. Pluto is now considered a dwarf planet or a large asteroid, but because there's many of those. Some of them, this one has, they're estimating that it has how much? Quadrillion? It's got rare earth minerals, gold, nickel. I don't know how to get it down, but there's people starting to think about how to mine this. Up here, we're getting hit about, this is another touchy-feely thing, about 20,000 meteorites hit the Earth every year. It said 48 tons, just a lot of material is coming down from space to hit us. A lot of stuff. Most all of it burns up. NASA's got a Psyche mission coming up that they're going to actually go out and look at this and see if it really does have the mineral capability, and then maybe someday they'll figure out how to mine it and get it back to Earth. It's cheaper than actually going and getting it. So where do they come from? So there's a couple of classes. There's potentially hazardous ones, there's near-Earth ones. There's quite a few things. Like most asteroids come from the asteroid belt. They bump into each other, something bumps into them, Jupiter's gravity grabs it, pulls it out, and puts it into an orbit that comes by the Earth. But there's also outside the solar system, there's the Kuiper belt and then the Oort cloud. There's another one way out there. So the ones that are way out here, we don't see very often. So the Oort cloud, yeah, that's probably where my data is. I don't know. So yeah, they have this cloud thing. Does anybody actually know where that is? And then there's these interstellar ones that come out. You know, where are they coming from and how are they getting here? And we're going to talk about that. And that's this 3-eye atlas thing is why I started this, because people kept asking me about that. So we're going to actually go and you know, the idea, will they hit us? That's the question we want to know, right? Will they hit us? Well, this is one called Shoemaker-Levy that actually broke apart into 21 fragments, some of them 1.5 miles diameter. And back in 1994, they were going to watch it hit Jupiter. So everyone pulled out their telescopes, and this is what they saw. So what do you think? If it could hit Jupiter, could it hit us? So I'm not feeling real touchy-feely about that, but it definitely hit Jupiter. So you know, we're out there. We're in the midst of it. This is I took this off of TV. Sorry, it's a bad one, but this is for looking at near-Earth objects, and interstellar ones is what we're going to get into. That's a bit on the scary side, don't you think? So the real question is, how big are those, and are they actually potentially dangerous? Well, anything that comes close could have been closer, so that concerns me. So we do have a list of 3 that we're going to talk about, mainly just these 2 here, and okay. I got a picture here. Now, I don't have any asteroid pictures, but I have pictures from some of the other ones. So who can tell me what that says? What's the name? Pronounce that for me, somebody. What is it? I'm not getting in. Umamumu, this lady right there? Okay. That's what it's named. I have a hard time with that. Boy, go to Iceland and look at their stuff. Everything's got 12 valves. So this is Oumuamua. I think we got that pretty close. Okay, imagine this. I asked my friend who's a planetary scientist, can't we go back and look and see where this came from and find out, hey, how it's moved through the galaxy to get here? And he said, it's never, ever, since its creation, seen anything else other than empty space. So for its entire millions of years of life, or billions of years of life, it's never run across another solar system. We wake up with the capability to look, and we see it come through our solar system at the only time we possibly could in the technology to actually see something from out of our solar system come through, and we just happen to see it. And now we've happened to see 3 of them. So something's going on there. So either there are a whole lot more of these that we haven't seen in the past, or we just got good at seeing them. So there's some questions there that need to be answered that I can't give you the answer to. Now this is coming from out of plane. That's how we know. All of the planets are going around in their little solar system path that you're used to from school. Let's just stick with that model. And this is coming from outside and swinging through. Now the chances of it hitting something were pretty low because there's so much space, but it was still there long enough for us to see. Now, when they look at this through a telescope, you're only getting a few, 2 or 3 pixels on their CCD, the device that's actually looking at the camera. Everybody has one in their phone, and so you can see there's a little bit of difference. So they're seeing, because it's rolling, that maybe it's long. They really can't tell how big it is from the distance. And like I said, they're only looking at 3 or 4. So there's a lot of imagination that goes into what one of these actually is. So people come up with, okay, so it's an alien spaceship, I don't know. So they infer a lot, from a few pixels. But, artists kind of have fun with it, so what the heck, I'll have a little bit of fun too. So has anybody seen Battlestar Galactica? Well, the whole show is about trying to find Earth, so maybe they actually did find Earth and they flew through and decided not to stay. Mr. Bugs Armstrong there's flying. All right, so we're not going to talk about the other one in the middle, but we'll talk about 3i Atlas. 3i Atlas has got it's been in the news, it's changing course, it's coming, it's, I've heard 2 or 3 real astronomers who actually have said stuff, and they're like, no, it's an asteroid, it's an asteroid. No, don't you think because it's an asteroid, kind of comet, it's just, no, it's not a spaceship. Well, it's not a spaceship. So anyway, so here's some pictures of an asteroid. These are some things that when they really get focused in on one that comes close, they can get some good pictures of. This one's slicing through in the plane of all the other ones. That's why we kind of worry about it, because it's like, okay, how can it be in the plane with everything else and be interstellar? It's just luck. It is starting to outgas now as it gets closer to the sun, so it's looking like a bit of a comet more than an asteroid. Those outgassing actually push it a little bit, so it moves it. As it interacts with Jupiter, it moves a little bit. So when it moves a little funny and people say, oh, it's moving funny, well, it's moving just like it should. So as much as we want to believe that it might be some kind of foreign alien object flying through the solar system, probably not. But however, just for fun, it is about the size of Mount Everest. So we probably don't want to get hit by it, so that would be bad. It isn't coming anywhere near close to us, by the way. It did come closer to Mars, and one of the ways, maybe I have a slide here, I'm getting ahead of myself. Like I said, this is the first time I've pitched this. One of the rovers on Mars, a navigation camera, and they were reviewing the data, and they saw it from the navigation camera, not any spooky telescope. And then once they found it, then everybody zoomed in on it and tried to find it. But like I said, this is actually a pretty big rock coming through the solar system. And the more they look at these things, the more they find out that, hey, it's really acting like we kind of expect, but it's acting way different than anything we've seen. But they can still explain it. And there's lots of these pictures, and people like to go add to the pictures. It's kind of fun, so I probably might do that in a minute. But you have to see that and infer a whole lot about what it is. So it really isn't coming anywhere close to us. One of the problems, though, is that if it flies too close to Jupiter or Saturn, they might grab it and change its course, and it might stick around for a while. We actually have a new moon for probably another 30 or 50 years. There was a car-size meteorite asteroid that came by and got caught by our moon, and it's actually orbiting kind of like our moon way out, and so it's going to hang around for about 80 years or so, and then it's going to fly off. So we have a small moon right now chasing us. So closest approach, not really close, 200 million miles away, that's not exactly close. Is it an alien spacecraft? I don't know. Maybe. So we'll go to one of the other ones that's more popular, almost. This one is 2024. They changed its name to Apophis because somebody wanted to be funny, because Apophis is like the god of chaos, darkness, distress, disorder. So some Egyptian guy. It's about the size of the Eiffel Tower. Yeah, pretty big. So it's going to pass by on Friday the 13th, next 2029. Sorry about that. Not very far away, 20,000 miles. Satellites, geostationary is about 18,000 miles out. So it's going to go between the moon and us. I'm going to call in golf, that's a gimme. If you put that close to the hole, you get to keep it. So if you're playing by, open rules, that's pretty much a hit, okay? So pretty big object. Would it be the end of the planet if something hit? Well, it depends on where it hits and what it does. I mean, if it hits in New York City, well, maybe we won't miss it too much. Did I say that out loud? I'm sorry. I'm sorry. If you live in New York, you're going to laugh too. I'm sorry. Sorry about that. I don't usually do that. So, but anyway, this is going to come close enough to take out some satellites, and it may possibly hit the moon. So this is it shooting out across the sky. And again, look at that's all we have to really go on. So people like to make up, renderings of what it could be. This is an actual orbit thing as it kind of flies through. If it hit, this is kind of what it would do. So luckily it missed the building here, So. This is in Arizona. 4% chance it might hit the moon. 0% chance of going to hit the Earth. So that's about what we would see if it hits the moon. It is not going to, it's going to put a dent in the moon. There's no atmosphere, so it's going to hit the moon if it happens to be in the right orbit. It might throw some debris out. That debris might come down. It won't be large debris chunks. It will be things smaller, and we might see a meteor shower associated with that and have a nice name of that. So how do we find these things when we look up? How do you find an asteroid or something that might be coming near the Earth? Well, there's a lady, Vera Rubin, and she is known for trying to explain dark matter and why the universe doesn't seem to work unless you add another 80% mass to the universe, which is they can't see, so they're calling it dark matter. So they made a nice telescope that was geared more towards finding something like an asteroid as opposed to something looking very, very deep. This is what it looks like in Chile, on top of a mountain. And we like to put it up as high as we can get it, in a place that we can still get to, but yet we have nice clean air, not a lot of weather storms there. You can see it looks like a desert area as well. And it's basically a camera, like a Nikon camera. They put it up for like $1,000. Okay, it was a little more than $1,000. It was almost $500 million. But compared to Hubble, 15 billion dollars, you could put 10 of these down very easily and start looking for stuff. Now there's something very hugely unique about this one. It does take a lot to maintain it, and it is a lot less costly than James Webb, and it does have a high budget. So I'm probably not going to buy one tomorrow. So Does look just like the Nikon camera, though, doesn't it? So how does it see? So this is the CCD charge couple device, which is what sees light. So it's a chip that they manufacture, an IC chip that they manufacture that has light sensitivity. This is Hubble. They have 4 of them, and then some smaller ones for looking at different things along the side. The light comes in and hits there, turns it into electrical signal, and then we can see it. So this is the Vera Rubin one. So this is the size of Hubble's CCD. This is the size, so 221 to 4. So you can literally, when it looks up in the sky, it takes a huge swath of the sky. It's not trying to see very deep. It's trying to take a big swath of the sky, and then it flips in filters to get the different frequencies, to get the different colors. And so it goes into an automatic mode because it's driven by AI. And so it gets a very big field of view. It gets to see a lot and gets to process it very quickly. So that's the actual picture of it. So you can see this is the actual kind of size. It's huge. The optical sensor is huge. So let's have a look at what it actually. So this came online this year, and this is what it did the first week online. So its first week online, it found over 11,000 new unknown asteroids or meteors that are out there. And you could see the little swath at sky, even with its wide, that was just a little swath of what they looked at. Imagine what it's going to find in the next 10 years. And so as it sees these, it's using artificial intelligence to find them. That's how come they find them so fast. It looks through all the pictures, does all that combining stuff in seconds that took days before, and it can pick out things that are moving. If it looks like it has a trajectory coming towards Earth, then they'll hand it to Hubble or James Webb and say, okay, now go evaluate what's actually going on with this, track it, find out if it's going to come near us or not. So Jupiter has a heavy mass, and so it has a tendency to pull things towards us, break things apart, and so we're not really sure if it's helping us or hurting us. But as we saw for Shoemaker-Levy, it sucked it into the planet, got it out of the asteroid business. Anyway. So what can we do if one comes near? I think we might have talked about this the other day a little bit. There's an asteroid called Bennu, and we said, hey, let's go there and let's take a sample. After it did this, and I'll show you a picture of it doing it, after it did this, they changed the name of it from OSIRIS-REx to OSIRIS-Apophis. And so now, after they finished its first mission to go and look at an asteroid and bring back samples, they sent it on to chase after 2024, Apophis. So and the European Space Agency has also sent one after it. So we're going to chase it down and follow it as it comes towards us. But this is, if you didn't see this the other day, this is it landing on and getting a sample to bring back. This is animated. The one before that was real. It actually almost gets stuck in the ground. It goes like 3 feet into the gravel, and everybody panics, and they blast it out using the thrusters and get it out unstuck. And then it brought back a sample to look at it Earth so they could see what it's made out of. But you can see it's actually very loose because there's not much gravity. It's very loose gravel. And so the idea is how many of them are like that, how many of them are rocks? I don't know. So we decided to try something pretty cool. We're gonna go do one of these missions where we go out and see if we can move an asteroid. So they have one called DART, Double Asteroid Redundant something test. And before they get to it, they're going to throw out another small payload that can watch what happens. Here's an artist animation of it going through the air. This is kind of the size of it right here compared to the two that they're going to go to. They're going to try and move this one. This one is in orbit around that one, so that's what we're going to do. The one they're going after is about the size of the Roman Colosseum. I got to actually see that. That's pretty cool. So here are the two asteroids. This one is orbiting. Now, the reason they wanted to do that is because when they hit this, they can actually tell if they've moved it, because this is their baseline. This is with reference to where it was, and now we can see if there's a difference. And the little CubeSat comes off, is going to map it. So this is the launch.
And liftoff of the Falcon 9.
I have to show a launch. It went on a Falcon 9.
First planetary defense test to intentionally crash into an asteroid.
Even if we do everything right, our sensors work well, our spacecraft is doing well, even then, you might still miss. 4, 3, 2, 1.
So I'll show you that again.
For the first time ever, humanity has changed the orbit of a planetary object.
So this is actually the footage from DART. That's pretty cool, I think. So that's so the idea behind this is, could we do something about it? The old thing, if you went up on the Titanic when they left port and moved the wheel just a little bit, then it wouldn't have hit an iceberg. Because a little bit now, early, means a lot later. So if we can move it a little bit a long way away, if we find it quickly, and then we can move it a little bit, and then if we really are getting kind of antsy, then we might do some things along the lines of putting something else on there that might go boom, but there was no reason to do that now. So anyway. So we're just going to go look at some of the larger impact craters that we've had, and then we'll kind of wrap it up for questions. So there was one that we didn't get to monitor because it was in 1908, but we saw the results of it and we heard things. It did an airburst, so it was a pretty big asteroid, 50 meters or so, 55 meters, 200 feet. Flew over and didn't hit the ground, it just blew up. It was going very, very fast. Lots of eyewitness testimony through the years that had been passed down, and it knocked down huge amounts of trees. I think a few people were injured. So that was one. This is another one that happened. This one's about the size of my house. So lots of camera footage of this one.
Нихуя себе, это что такое? О, нихуя метеорит, блядь.
Внимание!
Еба...
Это звук дошел, блядь.
Звук дошел от него. Слышишь?
Я на флаге, блядь, зажмуриваться. Ну, у меня вообще так жутко.
So they had lots of people recording it. That's what's going to happen. This one, it airburst. It broke up in the air. It didn't make it to the ground. But people are looking out the windows, and then the shockwave hits the windows, breaks the windows, and they get glass. So there was a lot of people that were cut by the glass, but no one was hit directly by it. So it's coming in at a very shallow angle, which means it has a long time to heat up and blow up. A lot of cleanup people. And then there's this one that we've heard about, the one in Yucatan. Have you heard about that one? It's pretty popular. Most of it is gone now. When you look at the impact, you can kind of see the ground a little bit, so it's really out quite a ways. So here's where it's going to hit. This is just me goofing around, sorry. Somebody said those guys are no more because of this. And here, if you had an artist rendering of what it looks like, it's mainly, there was a guy that was doing some geology, and he was flying over they were looking for oil, and he had a magnetometer in his plane. He was flying over, and the magnetometer was going nuts. And so he figured something happened here, and they started looking into it, and that's when they found out that it was a meteor or asteroid that hit the ground. I don't know about this one. This is a moon around Titan. I mean,
look at him, he's heading for that small moon.
I think I can get him before he gets there. He's almost in range.
That's no moon. It's a space station.
It's too big to be a space station.
I have a very bad feeling about this.
So I'm going to take a few questions now. Like I said, that's the first one I've ran that, so I didn't really have a time or anything on it. But I'll take a few questions, and I have pictures for that. So I'm going to put them on numbers up here, too. So what's your question?
The square mile array radio telescope, do you know anything about that? Can you tell us what that's going to...
So he's talking about a radio telescope. There are different telescopes that look at different frequencies. Radio means, what you hear from AM, FM. They actually have pretty large antennas. There's one at Parkes in Australia that they talk about. So there are different sizes, capability. I think we had one that just fell apart in the Caribbean. Which, what was the name of that one? Gazebo. I actually know the guy that was in charge of it, and I'm not surprised. Ready to go. So back here, I'm going to work towards the back, and I got one more little slide after this if you want to hang around for that, but that's okay. What'd you have, sir?
The one I believe it was called the DART, the one where the intentionally put it in the asteroid to see what it would affect. What effect did it have?
They moved that asteroid, not a whole bunch, but the reason they can tell that is because it was orbiting another one, and they could say that its orbit around that changed, and they could map it. They picked one intentionally to see if they could move it. It didn't move it a bunch, but if you find it pretty far out, then you can do some maneuvering with it. This is on 12, and it's a picture of somebody on the moon, Apollo something with Buzz Aldrin or something, I don't know. I'm going to go back here and be nice. Is there anybody up in the balcony that would like a picture? You have to ask a question. All right, how about the back row back there? I never get to you guys, and I always feel bad about people who ask me questions. Right here, waving your hand. From the ones that I've looked at around the globe, because I did show a quick picture, I'm sorry I cut through, of all the major impacts, it doesn't even show up as a major impact. So it's relatively small. I mean, some of these are like, there's one in Canada that they've been mining for materials that when it hit, it dug up the ground and left all of the gold and silver and titanium and copper close to the surface where they could mine it. And there's 100 mining companies. There's one in Africa they're doing the same thing with. So here's you a command module from Apollo. Yeah, it's on number 4 for you. One more, and then I'm gonna close up, and we'll go back outside. And there's one more thing I want to show on the chart. Yes. When is the last recorded asteroid impact? We have about 16,000 meteorites hit. Some are bigger than others. I think it was 16,000. Does anybody remember what that number was? It's way up there. We have a lot of impacts annually. So it is not uncommon for us to get hit. It's a commonplace thing for us to get. Size-wise, anywhere from a grain of sand to the size of a car. Most of them are smaller than bigger. There are a lot. I mean, there are a lot of small ones that we get hit often. Here's your Hubble telescope, or did I give you the other one? All right. So what I'm going to do now is I'm going to kind of finish one more slide, and then I'm going to go back out here in the back and if you have some more questions. But I'd like to get out of the theater, but so I don't get in trouble and I stay on time. Let's see. I did do, we probably need to deal with this, don't we? So let me work on that, so. I did want to say before I close up that I've enjoyed doing this. You know, I had fun doing it. It's fun for me. I hope you had fun. I'm trying to do it in a way where, you know, somebody would like to come and then they bring somebody with them who's there with, you know, they don't want to be there, but they're with there. So it's fun for everybody. That's why we throw in a bit of the rabbits here and there. So if you want to go to one of these sites here or make some comments some way to Facebook, or this is my email at this website, you can go there, and I'd like to know if there's some topic you want me to cover, or if you can tell me about all the things that I spelled wrong. I'm not necessarily going to be able to get to all the answers because there's a lot of people, but this website and this email are just for that. So let me know what you might want to hear. I'm always looking for new topics that might come out in the future. So thank you for coming. I will be around the ship. I can't get off. I think somebody wanted to go with me to dinner. I haven't even been to I'm with, my wife's not here. I haven't been to the dining room because I don't have anybody to go with. So somebody was going to come eat with me, I think, tonight or something. I don't know. Anyway, thank you for coming. Have a good time. And come get your pictures.